In this lesson, we're going to go over graphing systems of linear inequalities. Specifically, we'll understand what a system of a linear inequality is, and then we'll graph linear inequalities, we'll graph the system and find the coordinates of the vertices. Vertices is spelled wrong. Okay, vertices. So systems of linear inequalities. A system of inequalities occurs when there's two or more linear inequalities. So rather than just one linear inequality, we'll be given two that we need to graph. The solution, or the area that we shade, will satisfy all of the inequalities in the system. So it'll be all of the ordered pairs that satisfy each inequality. Okay? So example number 1, graph the system of linear inequalities. So my strategy for these is I'm going to graph each inequality first, and then I'll shade at the end. Okay, so for this first one, it's a less than or equal to, so we have m, b, and this is going to be a solid line. So our y-intercept is 0, -3. M is up 2 over 1. Okay, and this is solid. For my next line, m is -3, b is 9, and this is going to be a dashed line. Okay, so I'm going to start at 9. And then my slope is -3 or -3 over 1, which means I fall 3 and crawl 1, or go down 3 over to the right 1. Okay, and then this line is dashed. Again, if you're using pencil, you can just erase certain parts of the line to make it a dashed line. Okay, so what I'm going to do is when I shade the pieces for each line individually, and then wherever the shading for each overlaps is the actual region that should be shaded on the homework system or as a final answer, because those are all of the ordered pairs that will satisfy both inequalities in the system. Okay, so the system are those two, y less than or equal to 2x minus 3 and y greater than -3x plus 9. So for the first line, I'm going to keep it in blue, y less than or equal to 2x minus 3. This is 2x minus 3. And this would be shaded below. Okay, I'm going to go to -3x plus 9, and this is y greater than, so we're going to shade above. So above this line, and where the blue and the green overlap, and I'm going to do it in red, is our actual part where we should shade as our final answer. Okay, so this little corner here. So when we talk about shading the ordered pairs that satisfy the system, the ordered pairs in the red region, if you plug it into each inequality, both of them will be true. Okay. Example number 2, graph the system of linear inequalities. Okay, so again, I'm going to graph each part, and then I'll do the shading at the end. Okay, so y greater than or equal to x plus 1, m is 1 or 1 over 1, and b is just 1, and my line here is solid. So I start at 1, 0, 1, and I go up 1 over 1, and I have a solid line. Okay. For the next one, my m is the number in front of x, so -1 or -1 over 1, and b is equal to 2. So I'm going to start at 2, and then I'm going to go down 1 over 1. Okay. And this line is also solid. Okay, now I'm going to do the same thing in order to determine where to shade. So for the blue line, we shade above the line. And for the green line, we shade below. So where they overlap are all of the ordered pairs that will satisfy both inequalities or satisfy the system. Okay, so again, I'm going to draw it in red. This is the part that you would shade. Okay, the other shading, just the blue and just the green, are just part of the work in order to get to the final answer. Okay, graph the system of linear inequalities and find the coordinates of the vertices. Again, I'm going to graph each one, and then I'm going to shade, and then we'll talk about what it means to find the coordinates of the vertices. So y less than or equal to -2x plus 4, m is -2, b is 4, so we go 1, 2, 3, 4, down 2 over 1, and this is a solid line. And then x greater than -1. Remember, x is a number, is an equation of a vertical line. Okay, so I have a vertical line, and x equals 1. Okay, so for the top equation, oh, I should have done those in different colors. For y less than or equal to negative 2x plus 4, we shade below. Okay. And then for y greater than or equal to 1, let me do this in a different color. Greater than or equal to 1. So we have our vertical line. X values that are greater than 1 are like 2, 3, 4. So we would shade over here. So this part where the purple and the green match or overlap, I'm sorry, is the solution. So what I'm going to do is I'm going to draw it in red, and then I'm going to clear this out and draw it once so that we can look at the vertices, okay? So our the area we shade is the area in red there. Okay, so I'm going to clear this, and then we're going to talk about the second part, find the coordinates of the vertices. Okay, so I'm going to redraw the lines. Okay, and x is 1. And we determined that this was our shaded region. Okay, so it's a little bit cleaner. This is actually how it would look when you graph it on paper or in my math lab. Okay, so when it talks about the vertices are what form the solution region. So if you look down below, this keeps going on forever and ever and ever, so there's no ending point. But we do have one vertex right here. So when it says find the coordinates of the vertices, we're finding the coordinate of that point. Okay, so we know that x is equal to 1 there. We can probably tell that it's 1, 2. Okay, we know that it's 1 because of that vertical line, x equals 1. And then we can see from the graph that it's 2. Okay, but if you didn't necessarily know that, something you could use here is we've got x is 1, and if we plug that into the top equation, we would get negative 2 times 1 plus 4 is 2, would be our y value. Okay, so you can do it that way as well. We'll talk more about solving systems, linear systems, not inequalities, later on. But either using the graph or substituting the value we know into the other equation, because this point here is where both of them are the same. Okay. Thank you for watching. If you have any questions, please feel free to reach out to me.